Hey everybody. So hopefully you just watched the video of how to graph the equation y equals 2/3 cosecant 4x plus 4 pi over 5 plus 8. And right now what I am going to do is I'm going to help you figure out what the domain and range are, how we can write them. There's many options on exactly how you can write out your domain and range. I'm going to focus on, especially for the range, I'm going to look at it as interval notation. With the domain, I'm going to be a little bit more exotic there. So let's get going, shall we? So domain, I'm going to save for second, but I do write it first for whatever reason. And range we'll do first. The range is describing the set of y values that would be the outputs, possible outcomes, or dependent values relevant to this equation right here. When you could describe the range or the y values, obviously having a graph is super easy if you want to just analyze a really precise graph. So we're going to remember you start from the bottom y value, the smaller y value, and you work your way to the biggest y value. I know last year in Algebra 2, people got really good at domain and going from left to right, left to right, left to right. That range messed people up. Like, people want to follow a curve and go whatever way. So what I would tell people to do is to rotate your paper 90 degrees clockwise and find your range the way you would find domain, going from left to right, if that's better for you. So you could do the same thing and say, like, okay, where do I have, it's arrows pointing that way, so I'm starting at negative infinity. Where do I go until? Is it included or not? Union symbol, a little u, and then pick up at what y value? Because now the y-axis, if you turn it sideways to make sure you went the right way, the negative y value should be on the left, of course, and the positive should be on the right. I'll just keep it over here though, but you are more than welcome to turn your paper. Okay, so my range from bottom to top, as I said, I'm going to use a little interval notation. So I'm going to use a parenthesis because I don't actually reach the negative infinity. So parentheses are when you don't actually get to the number, and a bracket, squared off bracket, we use when you do actually hit that value, okay? Negative infinity, comma, and then smooth and continuous. We keep going, no interruptions until 7 1/3. Maybe you want to spice it up and change it to an improper fraction. I'm just leaving it alone right now. That number is included. We do have a point there, so I'm going to use a squared off bracket. And then I have this little gap. Even if it was like the tiniest of gaps, like one whole, one tiny, tiny number, you could still use this union symbol. Some books or worksheets might skip it and just start the next interval, but I like to include it, so I'm going to include it. Then I start up again at 8 2/3, and it goes up, up, up and away forever until infinity. Now, it's really just straight up carelessness when people take write down a domain or a range and don't look at it and see, does it make sense? Do my numbers or values go from smallest to biggest? Do they never overlap? Like, you would never go negative infinity to 8 2/3 here and then 7 1/3 there to infinity. Like, that doesn't make sense. If that was the case, it would probably just be negative infinity to infinity, but whatever. So make sure it makes sense. You know, if it at least makes sense when you have a mistake, that's a better mistake than when your answer makes no sense. All right, check it over. Now for the domain. So for the domain, we could describe it as, from, I'm going to use all the denominator 40s right now. Negative 8 pi over 40 until 2 pi over 40 with parentheses because it's not included there. Union, and from 2 pi over 40 to 12 pi over 40. And then are we done? Absolutely not. This goes on and on indefinitely in both directions. So we should come up with a better way to write this. You're not just gonna be like dot, 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 right? We really want to define it in a better way. So my domain is all real numbers such that x does not equal, so the domain, it's like we're saying it's everything except these things. So I'm using this little backwards looking E, it's like a sideways U, with a line in it. And then we're going to use it turned the other way. Or whatever, I think that's fine. Yeah, because there's a couple ways we could write it. We could write it with a vertical line and whatever. I'll spice it up next time. Such that x is not equal. Now, what I usually do is I'll describe the first asymptote, and I always leave it with the common denominator one because it helps me see the equal space between all my asymptotes a little bit more. So the first one in my drawing is x cannot equal negative 8 pi over 40. That's the first place where it cannot be. But also plus, what we're going to do is we're going to describe how big is this space between asymptotes. When will we see the next one? And then the next one and the next one. How far apart are they? Well, if the quarter period is 1 pi over 8, which became 5 pi over 40, then we really want half, so we could double that. So it's 10 pi over 40. If you check, negative 8 plus 10, yeah, it makes sense, 2 pi over 40. So plus 10 pi over 40. But you don't just add it once. Sorry, it's so little. You're not just going to add it once and be good. So we put n because you can add it any number of times. Got it? So n, comma, but we have to describe n as being either a number like 1, 2, 3, 4, 5, dot, dot, dot. Or it could be 0. Or it could be negative. We could subtract and go the other way. What are those numbers called? Those numbers, 1, 2, 3, 4, 5, hey, 0, negative 1, negative 2, negative 3, are what we call integers. So comma, n. Now I'm going to do the e the other way, kind of like this, like a sideways u, is an element, that's an n, and then the element in the set of integers. And the set of integers is a capital Z with an extra slanty line right there, and I always cross my z's so they don't look like a 2. So the domain, we're saying the x values, your family's telling you who you can hang out. Oh, you can hang out with anybody except that person. And then every 10th person after that. What? I don't know. They're weird. So all real numbers, x could be anything, such that, wait a minute, disclaimer, like a little, stipulation, x does not equal negative 8 pi over 40, that was our first vertical asymptote, undefined, plus any increment of 10 pi over 40, we could add it once, twice, 0 times, we could add it negative 1, negative 2, negative 3 times, and the n is there because then n can't be something like a half. So if I add half of 10 pi over 40, well then I land in the middle and that is okay. So why would I be saying x can't be that? So I know this is our first time having this talked at you. We haven't had a conversation yet as a class. If you are, depending what class you have me for. But I hope that this kind of makes some sense. So if it does, you're like, I understand. I don't know if I could do it by myself yet. Thumbs up. And if you're like, no idea, you just wrote hieroglyphics, thanks for nothing, put a thumbs down. It's anonymous. I don't know who you are doing it, so I don't care. Not hurting my feelings. But I hope you copied this down. I hope you at least tried to understand it as best you can. And I hope you have a nice night.